Hey, Stats. How's it going? Good? Good. It's an AMI day, so I wasn't expecting a back-to-back AMI day. So we actually have to learn stuff new today. Sorry. Not sorry. Um, so I posted all the notes for the entire unit already online. I didn't hand out the note packets on this section, sadly, already. But the filled out note packets are already on the Google Classroom. So I highly, highly, highly encourage you actually looking through it today. Um, it's actually not a bad read, and it's pretty straightforward and hopefully should be familiar. There's a lot of vocab. It's very vocab heavy, which is why we're going to spend 2 days on this, being today and the day we get back, knock on wood, on Thursday. We just simply don't have the time to have a free day. Stats is a lot of content, actually. So I think it's the most content out of all of the classes, with the exception of pre-calc algebra. But this is just content heavy, and I think these are very, very actually well written and very straight to the point notes. Now, if once you look through the notes, this is just kind of a summary of all the topics it goes through. So I highly encourage you to take a glance through the notes first and then come back and watch this vid. Because we are going to talk about them and summarize them, and then you'll have your 2 questions to answer, of course. And there's one specific thing they don't go through yet that I think is pretty cool. And mathematically, if you have a stronger math background, like some of my double up math students and pre-calc survivors and college algebra survivors, then this will be right up your alley. But if not, then we can tune out. But the ending result will be kind of cool. So firstly, they talk about SOCS. So this is actually how you describe data the proper way. Usually a lot of people leave out this stuff, especially when you look at news headlines, right? They usually just talk about the center, but they don't really talk about any outliers that may occur, spread, any nitpicks about the sample size, which we'll get to later. But SOCS stands for shape, outliers, center, and spread. So this is how you want to describe data. You remember in the pretest, the very last question was describe the center, shape, spread, and well, there were no outliers on that one. And mathematically, we'll actually go through how to find outliers either in notes 1.4 or I think at the end of this section. They give you an idea of how to go about it with the IQR, with the upper and lower boundary and fence and stuff, which we'll actually go through in class together because it's a little confusing. So I usually like to explain it a little bit better that way. Anyway, but it is how you describe data. It gives you an idea of what's going on and answers a lot of the questions if you answer the what's going on with the data kind of thing. So first, let's talk about what shape actually means. They give you really good examples actually about the shape. So 6 different aspects you want to look at is whether it's unimodal or bimodal, right? Uni meaning one hump because uni means one, since you got unicycle, right? It's got one wheel. Unicorn have one wheel or one horn. Bimodal being 2, right? Because bicycles have 2 wheels. And that's going to be more of a double hump thing. But the 3 main ones that we're going to be looking at for the rest of the semester are these 3 main ones. It's good to be familiar with the terminology and not to get unimodal and uniform mixed up, because uniform is pretty much all the same height. That means that it's pretty spread around evenly. Like on that one question about the, oh gosh, the best, one of the breakfast questions, but it had pretty much almost a tie, 4-way tie with one of the questions. I forgot which one it was, but anywho, but unimodal symmetric, which there's a bell curve shape. We're going to be looking at that, and there's a normal way to describe it. That's a pun, but we haven't talked about normal distributions yet. That's a very specific one. And then skew left and skew right. So skew left being that you have your tail on the left side of your distribution. Tail, if you were to plot out all the bar graphs and everything, then most of the data would be in this kind of area. However, there's something very specific, especially at the end, that they describe about these nodes. Whether or not you have your mean and median, which let's talk about mean and median real quick. So, and we're going to skip outliers for now. Center being mean, median, and mode are the 3 main ways to describe your center. There's multiple ways. Mean being your average. You add them all up, divide by however many they are. That's typically the way we go about it. However, some of it might not be resistance to outliers, which we'll get to in a second. Median, the 50 percentile mark, meaning if you were to line up all your scores, where would the median or where would the middle be? And a good way to do that is to line them all up and cross them off from left to right, one each. And then your mode is the most often occurring one, which all three have their rights or their nice ones to go, or they have their time and place. So those three are the main ways, but we're going to be looking at the mean mostly. And then you got your two different symbols for the mean, which you might see it as X bar, where you got an X with a bar on top. That's usually the sample mean. And then you got your Greek letter mu with a little X next to it, because that's describing the discrete data variable. And that's going to be for your population mean, which we'll get to later on, just to give you some exposure to it. And then the median I usually create as med. We'll talk about spread later on in the semester, and we'll actually do it not tomorrow in person. But let's go back to outliers. So outliers are simply just data points that aren't like the rest. Conceptually, that's the way it goes. Like, for example, if you got test scores are always the best way to describe it. You got most of the data or most of the class is scoring around 85 to 95. And then you got some goofball that scores at 20%. That would be an outlier because that's not like the rest of the scores. And mathematically, there is a way to find it, which we will go over in class. I think they go over it in here too. So if you're able to understand in the notes, good. But we'll actually go through a few examples so that we can actually mathematically find them. But resistance to outliers are typically better for medians, right? So, but means they pull down. Outliers usually pull down or pull up data, which is what the skew means. So if you have outliers that are pulling down your class average, it's going to be skew left, because usually most of the people are all the way over here, right? But then the average is going to be kind of over here, because once you add in that 0%, then that brings down the average immensely, especially if you have a smaller data sample. Now, if you have like 100 students and you have one person miss it and get like a 20%, that's not going to pull it down as much as if you only have like 5 people in the class. That's going to pull it down so much more. And that's because, you know, class averages are the sum of all of your data points. So that little sigma divided by however much there are. So the more people you have here, the more it's likely to kind of cushion your data a little bit versus, and that's going to lower your spread later on, which we'll go into later about why that is. But there's more examples than just test averages. Question 1 that you're going to have to answer in the Google form is, when in real life would you be able to find skewed data other than test averages? You cannot use test averages as an example. I want you to figure out and try to brainstorm some ideas about when you would find skewed data. So that's going to be question number 1. And a follow-up question to question number 1, because I just thought of it because I thought it was really cool. So part 2 to question 1. It's not question 2. This is not question 2. This is part 2 to question 1 is, what can skew data? For example, if you were to ask a question, the same question in a very specific way to add some bias, would that skew your data? That's actually a hint to that, but it's a follow-up question. So I guess question 1, just to recap, is where would you be able to find skewed data, and what can skew the data? Try to think about that. It's a very interesting question. That's what I kind of love about stats, actually, is that you really get to dive deep into it and like really pick apart some things about real life applications. Argue with me all you want, you'll never graph a polynomial in your life. Probably right. But if you argue with me, you'll never use stats in real life. Oh, that's just a lie. They're just straight up lie. You actually get to use this stuff, and it's really cool. Now, the other thing I want to get to, the mathematical thing about it, is about your mean, right? So if you were to, by chance, go through what the mathematical mean is, well, let's take a look. So the sigma symbol represents add them all up, right? So here's the definition of what a mean is. So it's X bar is typically the sum, meaning all of your data points added up, of I equals 1 to your first data point to big N, however much you have. So all over big N. So this is the mathematical definition of mean. And actually, it's a lot more complicated than that. However, it's the basic college mean definition. The actual one, if you're curious, is the expected value of a discrete random variable function, e of x, which if you're wanting to go down that rabbit hole, I'll go there with you, and I'll guide you through that rabbit hole. But anyway, if you were to think about this from a perspective, one, you'd be able just to factor out that 1 over n, and because dividing is just a fraction, isn't it? And what this actually represents is if you're to write these all out, so just to kind of walk you through some more math vocab and symbols so you get more comfortable with it. But what this actually represents is you're adding your first data points. Let's say you got 10 people that are taking a test, right? So this is going to be your first person scores plus your second person scores plus all the way up to the 10th. So if this were 10 people, then you have a 1 over 10 there. So n equals 10. So n is just your sample size. And this would be a 10 as well. So this is your 10th person score. Now, this is what the mathematical mean is. But a really cool question that you can ask with this is, if you were to double everybody's score that took that test, would it also double your average? Is it going to be that easy? Or is there something that needs to be done? Well, it's a very interesting question. Or if you were to take everybody's score and just add 10 to it, would it just add 10 to your mean? Is that how it works? Well, there's a way to actually prove it with math. So here is a really cool hand wavy thing that you can, well, not hand wavy, but let's get into it because it's an interesting topic. So I'm actually going to go through a little bit more mathy stuff with you. So firstly, let me just make a little bit more room. If you're to double your scores to everybody, would that double everything? Well, let's take a look. So if you were to double, meaning I equals 1, 2, and double everybody's score, so multiply everything by 2. So there's a little 2 there now. Well, then you can rewrite it just like we had before. So 1 over n. And then it would be 2 times the first score plus 2 times the second score plus all the way to 2 times the nth score. So, for example, if you had 10 people, then that would be 2 to the 10th. And then what you can actually end up doing is, I know, use the factor word, factor it 2 out. And this is where it gets really cool. So you could factor it 2 out of all your data points. So there you go. Factor a 2 out. Bring the 2 out all the way to, with the n, so 2 over n now. And this represents that, yes, if you were to double everybody's score, it would double your average because this would be the definition of a mean. So, and I guess the last line would be 2 times x bar. The definition of x bar is the sum of all of them. Now, this whole little thing is called the mathematical proof by algebra, which is something you do a little bit in geometry. You usually do those 2 column proofs, but usually when you get to big boy math, this is the kind of way to do it. So that's how you mathematically prove that adding up or doubling every single score actually just doubles the mean as well. And the same thing can be done with adding and subtracting all scores, right? So if you were to add all the scores up or add 5 to every single score, then it would add 5 to the mean. And you could do that very similarly with a mathematical proof. So instead of putting 2 times, you could do x plus 5 or whatever, and you can prove it that way. That's not going to be question 2. It'd be really cool, but this is not honor stats, really. It's just basic stats. There's honor stats that make you do it. But question number 2, though, is a stat of the day, just like before, because, we got to be consistent with our stat of the days. But find a stat of the day that's something on your mind right now. So something that's pressing. It could be, since everybody in this class is senior, except one, like, what's on your mind about graduation, right? You only got a few more months. What's on your mind about something? Look up some stats on it, right? So, and then find what your findings. Find an interesting one and post that as your answer for question number 2. If you have any questions, comments, or concerns, let me know. I'm more than happy. And hopefully see you on Thursday.